Welcome, ladies and gentlemen. Welcome to LOPEC Talk number 9, December 8th. Today, we will give you an update today on LOPEC 2023, but we will also take a look on highlights of our LOPEC this year. Let me take a brief look at the agenda so that you have a chance to see what we are going to see today. I will introduce briefly also our guests today. We have some guest speakers. The start of the talk will be today that we will give you some talks which we have from our last startup competition. We want to emphasize even more and more that startups at LOPEC play a very important role. We have awarded 2 startups last year, and they will have a chance to introduce their business case and also their technology during our LOPEC talk today. So we have from Copprint, Offer Schochet with us. We have from IoTech, Ralf Birnbaum with us, and I will briefly introduce them in a moment. Then we will take a look at LOPEC 2023, what we want to do there for the startup competition. And we have with us John Falteich. He will be our startup chair. Also, I will introduce him shortly. And we will take a look of what are new things there which you can expect. And then I will give you an update on what you can expect from LOPEC 2023. So let's get started with our LOPEC talk today. That is the award-winning ceremony of this year's LOPEC. Stan was announcing all of that, and here are some pictures of the awards given by Michael Corell from Evonik to Offer, and also this is a picture of the presentation on the LOPEC forum where IoTech has presented, and these are the 2 winners of the awards from this year. And we thought they only had 5 minutes pitch. They, of course, the jury was convinced about what they presented, but they should give a chance to present what they are doing, why they've received the award. So that's the reason we invited them to today's LOPEC talk, and this is what we have here on the program. So I would like to call Offer. If you are here, please come on stage. And he won the award. Hey, Offer. He won the award on Best Business Case, and there are good reasons why you won the award, and probably you have already moved further since March this year. But I'm really looking forward to your talk presenting your technology.
Thank you, Wolfgang. Just to verify that you can hear me well?
Yes.
Perfect. So I will share a presentation and want to see that indeed you can see that. I want to see, it seems to me like March was 20 years ago, not just less than a year ago. And much has been done at least on our side. I will try to touch a bit more of that, but probably the key thing for us is that after LOPEC starting to get significant orders from customers, multi-tons order, and moving into a lot of new applications. But let me more start just with what we are doing. Well, I see some sign here. Let me see how I can move it. Thank you. That's it. So at Copprint, we are transforming the way people are making conductive pattern. We are offering copper inks, just as you can see on the right-hand side. So there are inks maybe more viscous as paste. They look like chocolate, just a bit more shiny. And we provide our customer with a value of a lower cost for manufacturing, sustainable manufacturing, and having it in reshoring. And by reshoring, we mean that it's about time that we have more manufacturing in Europe, in the US, and not necessarily just in Asia Pacific, as we have seen recently. We are providing our ink and actually as a replacement for silver inks that are usually 5 to 10 times more expensive, or PCB etching, which are a process that is very hazardous and polluting. One last comment about Coprint as a company is that Coprint is a startup from Israel, and we are backed by top strategic companies, Henkel, HP, and Tatsuta, and we are grateful for them for their supported Coprint so far. So as an overview, we are working in the world of electronics. I mean, everything at LOPEC is. And for us, electronics is everything from displays, your computer mouse, your car. An average car has about 4 meters of PCBs. The EV have twice than that. Photovoltaics, all of these are using conductive patterns. And it's a large market, just a conductive pattern for electronics, more than $70 billion. And today there are two ways to make conductive patterns. One is using chemical etching processes. It's a process where you usually start with a metal sheet. It's usually copper. You glue it to a substrate, usually FR4, and then chemically you're cutting it after actually you printed a mask on top of that. This is the most common way to make circuit boards. People call them printed circuit boards, although they are not really printed, they are etched. And most of this activity of manufacturing is done today in Asia Pacific. About 90% of the world PCBs are made there. There is a lot of waste. It's toxic waste, not fun chemicals to work with. A lot of water consumption, and these things are not really allowed, or are very expensive at least, to handle in Europe and in the US. The other way to make conductive patterns is more additive, just by printing, and this is done today with silver inks. First silver ink were invented by DuPont about 100 years ago, and today they are used only when needed because they are very expensive. There is also a toxicity issue. The biggest usage for that is for photovoltaic application, but if you go around the LOPEC show, you will see a lot of people printing silver today on substrate like PET, like polyimides and other flexible substrate. So at Coprint, we are making ink that are made from copper, as we showed earlier, that you can simply print. On the right-hand side, you can see an example where we are printing RFID antenna on paper. So just pushing the ink through this stencil to make the antennas. And in terms of our vision is to provide a solution that has lower cost for manufacturing, more sustainable, both on the manufacturing side and on the usage side, or the end of life of the product, and to do it with some reshoring. So moving from etching to printing make a lot of sense. The processes of etching are very cumbersome. There are a lot of steps. There is a lot of waste. And for printing, you just put the right amount of ink wherever you want on the substrate. And also the comparison between silver and copper is very simplistic. Silver as a raw materials is about 100 times more expensive than copper. The conductivity of silver is about 5% better than copper, but all other parameters like carbon footprint, like toxicity to water, like abundance, copper wins very, very easily. And therefore the interest to move to copper. With copper inks, you can see on the chart comparison to a lot of silver inks, you can see that the copper ink has a higher, they have higher conductivity and faster processing time. And we have today quite a lot of inks that people can buy in order to print on paper, on PET, on FR4, on photovoltaic cell, and people can use different printing, not just screen printing, as I mentioned, but also dispensing, flexo, gravure, lift, like the presentation of Ralph from IoTech after my presentation, where they are also using the copper ink in their process. So we are in serial production now. We have a lot of inks. There are details that I will not go in such a short presentation. I will just mention that there are 4 parameters when you compare different inks: the price of the ink, the conductivity, the coverage, and the minimum printing thickness. And all of this will determine your price performance. And as I mentioned, with copper, usually we are getting 5 to 10 times better price performance than silver. So our process is very simple. You can see it on our website for simple printing, and then a short drying, and then, jumping too fast with the slide, and then a very simple process to do the sintering. I will go it very quickly, just, printing, putting it in a office laminator that costs $200, and then you get a conductive pattern after that. For our customer, what is most important is the durability, not just the fact that it's conductive. It's need to pass a lot of thermal humidity tests, to be solderable, to have a good adhesion, to go through bending tests, and that's the key for all our customer. In terms of market, we are active in the world of RFID, in the world of photovoltaic metallization, and also in the general world of PCB. Probably just few examples in the world of PCB, moving from, on the left, etching processes to simple printing on the right, using CopPrint. You can see here a simple PCB that was constructed with our technology, a two-sided PCB actually with the touch capabilities. I will just say that it's cheaper to do printing than to do etching. This is an image from Innovation Lab and ISRA of a two-sided or two-layer PCB assembled with humidity sensor, even solar harvesting. Recently, Volterra, for example, showed system that can do dispensing in a digital way to the copper inks. Transparent displays that are made with our ink. We hope to, in a few weeks, we can show a more released product from customer on transparent display, copper printed on glass. Here is another example of copper printed of glass from a Chinese customer of us. And another example, making LED boards by making street lamp or doing street lamp in an additive way, not using etching, lower cost. These are pictures from a customer in Korea, including this weird video with where you can see the street light active in a rural area in Korea. Maybe to summarize here and leave some short time for questions. We have a proven technology today. We have top customers that are adopting our technology, a very large pipeline. I can say that the last year since LOPEC was very fruitful, and also getting the LOPEC award gives you a lot of credibility for people in the market. And our key messages: lower cost and sustainable. People are not willing to pay for sustainable solutions. They are not willing to pay extra. So you have to provide lower cost than existing solution and a sustainable solution, and then customer will adopt it right after that. So that's about it for my presentation. If there are any specific questions, I'm very happy to answer those.
Thank you, Ofer. Thank you for this impressive showcase of CopPrint's world of printed copper. I've just, looking at the questions, at least one comes to my mind. It seems the application seems to be limitless, but probably there are some limits, and probably there are still some challenges you are working on. So what would you describe as, where would you advise people to wait a bit more until you solve the challenge, or where the copper print material is not yet there. So is there limits you can communicate, or is that something you are still working on?
Yeah, I mean, first, for every customer or application, that there are different requirements, and when we are working with customers in the photovoltaic world, the tests there, these are usually 3,000 hours of thermal humidity tests to simulate 40 years of operation. So they just take many months. So everything is slow in terms of the testing and adoption. We have enough experience. By the way, we have photovoltaic solutions that are working today with copper inks and pass all the industry tests. So I recommend to customers to start adopting it earlier, and then based on their requirement to do the right test. There are already markets we've done significant tests, like the RFID market, like transparent displays, like printing on PET for quite a lot of application. So we have enough data that we can share with the customer, and they know how far it is for approval. At least a lot of customers have approved it already and are working with it on a regular basis.
Okay, so that I take as the advice is get in contact and let's say start to adopt it, which means still it's a project. It's not yet a standard project as we have it in a lot of printed electronics areas. You will see the advantage if you try it, but you need to check it first.
I think that in the whole world of printed electronics, from the side, everything looks simple. And then when you have your own project, you find out that there is some process adjustment, there is some specific issue that relates to the specific product, whether you need to integrate additional components, etc. So it's not that different than status, I will say, already of other solution in the printed electronics world.
Yeah, no, definitely. And just looking forward onto LOPEC 2023, we will have a discussion there about standards. We probably need to go to standards, but that means also that our technology needs to be more and more mature, and that applies to all components like yours. Thank you for that very nice presentation. I don't see right now any further questions, so thank you, Ofer, again, and we'll probably see you at LOPEC 2023, I suppose.
Oh, definitely. We just booked our booth last week.
Great to hear that. Yeah, and let's move on. Let's move on to Ralf Birnbaum from IoTech. He is the second winner. He won the award, or his company won the award for most impactful technology. And I already heard from, or we heard from Ofer that you are doing something on the production side. And so I'm really looking forward to your presentation and the insight on what you can, or what we and the customers get as a value if you use your technology. So please.
Thank you very much for that introduction, Wolfgang. So indeed, we were awarded the Most Impactful Technology Award at LOPEC last March for the technology that we have developed that we call continuous laser-assisted deposition. I gave a very brief overview in March, and I shall be repeating some of those slides for those of you who are not there. So I will go quickly over the technology, and then I'll be adding with some applications that we have succeeded in printing with this technology. Some of them are also with Ofer's copper inks that he just presented before. So also I'd like to thank our backers. So we are backed by ASMPT and also Henkel, just like Copprint. We are also backed by the materials vendor Henkel. So this technology is a contactless technology for electronic manufacturing with which goes at high speed and also high resolution. It can be used for many different applications along the electronic supply chain. In this presentation, I'll be showing just, I think, 3 different applications. But basically, your imagination is the limit. Anything you can think of, where one material is somehow being added to another, we should be able to print. Now, one of the key differences is that we print standard certified materials. So no reformulation of the material is required, because we can deposit materials up to extremely high viscosities too. So traditionally, you have non-digital technologies, for example, screen printing, where there's some kind of mesh which imposes a constraint on the layer thickness as well as on the resolution of the design. Traditional digital technologies will often have a nozzle, where the nozzle imposes a constraint on such things as the viscosity of the material, because if it's too viscous, it'll block the nozzle. The speed, the nozzle needs to be moved around mechanically, and also the resolution. In continuous laser-assisted deposition, which is a contactless technology, so there's no nozzle and there's no mesh, which removes those constraints, giving you full flexibility. So we can control the thickness of each layer. We can print materials of extremely high viscosities. And of course, we do that at very high resolution and basically the speed of the laser. The way it works is on the left here, you can see a dispenser, which dispenses a material onto a thin transparent foil, which then carries the material through two rollers to guarantee a uniform thickness. It goes underneath the laser. The laser delivers a brief, powerful pulse of energy, which creates a vapor bubble, pushing a drop of the material onto the substrate below. And it can then do that over 2,000 times every second. Any unused material is then carried back to be recoated and reused a number of times. In video form on the right, you see the material being deposited onto the carrier, goes through the cylindrical rolls underneath the laser, whereby a drop is released onto the substrate below. I'll re-show that again because it goes quite fast. The carrier carries the material under the laser. There's that brief pulse of energy. And there you go. There is also place in the machine for post-processing. So we can also add a UV curing or a thermal curing station within the machine. This will be especially helpful for any kind of additive manufacturing application. If you want to do multiple layers that require some kind of curing in the middle. For metal pastes, the same laser used for the CLAD can also be used for the sintering. And also any excess material can be ablated away with the laser. Resolution, so there's dynamic resolutions. We can go down to 20 or 30 micron. We actually print a little bit higher than that, but we can ablate excess material away. And also very good accuracy. Productivity is 1 meter line per second or 7 million drops per second. To give you an idea of how much that is, for jetters will print between 70 and 100,000 drops per hour. Here we're printing almost 2 orders of magnitude greater, 7 million drops per hour. To show you in real time, you can see the operator here on the left placing the substrate onto the machine. The printhead will come over the substrate. The material is being deposited onto the carrier film, and the laser goes to work. 1, 2, 3, 4. Printhead moves to the side, and you see one single printed circuit board layer. I like that so much, I'm going to show it to you again. So this is real time. You can see how fast it works. This is, of course, only a small substrate. We can adapt for larger panels, of course, too. That was the material, and that's the laser going to work. So we've tried and tested quite a number of materials. Here's a short list of some of those materials. with a very wide range of viscosities. So you can see silicon up to 300,000 centipoise or 300 Pascal second. It is that viscosity as well as the filler size, the particle size, which will define the kind of resolution that we can achieve. So of course, different materials and different rheology of materials will give us different resolutions. We've also included materials that require different types of curing. So another advantage of this technology is that we can have multiple materials in the same machine. So we can print up to 5 different materials. It's just a question of the implementation, of course. And here are some applications where that's required. So for example, if you want to print an outer layer of a PCB and the solder mask in the same machine, here in the top left corner, we can print multiple adhesives or different colored adhesives. And on the right is an application with 2 very different materials. So this is a lead centering application with a glue dot in the middle, used especially in automotive headlights to make sure that all the LEDs are perfectly 100% aligned. A small epoxy dot is placed in the middle, and the machine. So with this technology, you can print the solder paste and the epoxy dot using the same machine. No handling would be required, no moving to another machine. Everything is done in one station. So comparing to other similar technologies, so we like to call this technology a digital screen printer just because of the high throughput involved, but with all the benefits of the digital solutions. So it has, and also just like screen printing, it can print all industry standard materials. So no kind of, any material that has already been certified does not need to be reformulated. That's the material, the way it is, that's how we're going to print it, which is not the case for most other digital technologies. We can have very high resolution and accuracy. We can print multiple materials, and we include post-processing in the same station. Printing inside a cavity is also possible. So, for example, if you have a cavity with a chip, we can print the traces down into the cavity. And of course, also we can print in the other direction, in the Z direction going up, allowing for additive manufacturing applications. Okay, so that was a brief overview of the technology. And I wanted to give you some examples of applications that we've tried. We've received many requests from customers for a very wide range of applications. At the moment, these are the ones that we're focusing on, more or less. So, of course, these are just 3, but there were many more. So here are some lines that we've printed with this technology. These are not especially fine lines, these are 90 micron lines, but you can see how the edges, how smooth they are. So we can go down to, so as I said, we actually print 50 micron lines, but we can trim them down to 20 micron. We can also, so if we were to, we haven't yet built a PCB, a multi-layer PCB with this technology, but if we were to do that, we would be basically printing the copper vias as we go up. So there will be no drilling involved. So we can print, we can create such through holes of 200 micron or via sizes as we build up 60 micron, because that would be the minimum amount that we could fill the existing vias. And a copper height, we can print roughly 10 micron thickness, but of course, it's 10 micron and above. We could also go up to 35 and 70 micron. And if we print multiple layers, we can go above that as well. So there are many benefits. There's, of course, no imaging or developing or etching involved here. So it's a much more simplified process, taking up much less floor space, and there'd be no wet chemistry. So this would also be a huge benefit for the onshoring that Ofer spoke about earlier. Being digital, there's no wet chemistry for regulations. That makes everything much easier. And being additive, there's also a lot less material wastage. So we are adding up the material. We're not putting all the material and taking away what we don't need. Speeds are production, basically industry speeds. The resolutions is for the majority of the PCB market. This will be okay, except for the extremely high, finite HDI. So 20 micron and above is good. Additional benefits are, as opposed to chemical etching, there's no undercut. So we build up the straight walls of the lines. And because it's non-contact, we can also use non-planar substrates up to a limit in thickness, of course, including going down into cavities and going up as well. The second application is more for the semiconductor packaging field, where a chip is being connected electronically to the substrate using copper pillars with SAC alloy on the top. So this is another application that we've done some work on, and there are many benefits here as well. So here too, again, just like with the traces, it's a simplified process with just one piece of equipment to do both the copper pillar and the topping, the SAC topping on top. It's additive, so a huge saving in materials, and there's no wet chemistry involved. Because it's we can print iteratively, we can print and see what we've done using SPI. So we can make sure that everything is, the copper pillars are all increasing in size at the same rate. Big benefit as opposed to the current method of electroplating is that all material that is put there is actually used. Nothing is being thrown away with the solution. And also any kind of impurities in the bath could, in the electroplating bath, could create pillar voids. So that's another issue that we, of course, do not have. Another benefit of being digital is that we print only where we want. So when, as you know, semiconductor dies are extremely expensive. We don't want any die that is not good. We don't want to use. We don't want to increase the value. So we only print on what is known as the KGD, or the known good die. And the third application is solder paste deposition. We could go up to very fine resolutions of solder balls down to 60 micron. A standard type 6 would be roughly 100 micron diameter. I believe that that is better than what is currently being done with screen printers and digital solutions for a type 6. We can print multiple component sizes, large and small. We can print on top of components as well, allowing multiple chip stack applications. And of course, we do all of this at very high speeds. These are some close-ups. We can print any shape that we want. We have a raster image of the shape. Can have squares, oblongs, ovals, what are known the house shapes of solder paste balls as well. So when we printed on a number of different PCBs, different BGAs with an indium type 6, as you can see, all the diameters are all bunched together. So we have got some very good results. And here are the numbers. So for the radius, very good standard deviations of the roughly 400 solder balls on each BGA, with a very good CP as well. The same for the thickness. So the maximum thickness of the solder balls, they must be as even or as uniform as possible. So got a very good standard deviation there as well, below 5%, with acceptable and high CPs. And ratios, also the ratio between the thickness and the radius are also very good. I think that it might be a mistake. That's correct, radius. So we've got good ratios here as well, very high radio. And as you can see, the volume of drops are very small, nanoliter, and we can control that volume with the various parameters of the laser. So to summarize, this is a solution aimed at mass manufacturing. It's not just for prototyping, although it can be used for prototyping, but our strategy is to build a machine that will be useful for mass manufacturing. Being contactless, it can print highly viscous materials, some materials that until now could not be printed. So we are opening the door to use a wider range of materials. The ability to print, to control the volume of each individual drop also gives us a lot of flexibility in design. We can combine different materials as well, because we can print up to 5 different materials. We don't sell inks. We will print your materials as long as they can be pasteable. So we're not making money on materials or anything like that, which also keeps your costs down. There's no other expensive consumables. Keeping the post-processing inside the machine also saves you on machine, on manpower, on floor space, and on handling costs as well. And of course, we do this at very high speed, and it's just a simpler production process. So the way we summarize it is we're giving you the productivity of the non-digital solutions with the flexibility and precision of the digital solutions. Thank you very much.
Thank you, Ralph. That is impressive, definitely. So yeah, I'm very interesting to see all of this. Maybe I start with the immediate question of where are you in scaling? Are you selling machines? Are you selling the process already?
Yes. Yeah. So we are selling machine, but we reserved 2022 for a beta program. We have installed 2 machines at customers, and they have been giving us feedback on how they would like to use the machine in production. And we've been stabilizing the process, optimizing it, getting the kind of results that the customer wants, not what we think they want. And we have finished with that program now. So in Q1, we can start selling machines commercially. We have already quite a backlog for that.
Okay, very good. I have seen one question which is also coming to my mind. You showed us a lot of sheet to sheet, so printing on a sheet. Can you print also already on webs, so roll to roll? Have you tried that? And what is the widest width you can do with your process?
Yes, that's a good question. So currently, because it was a beta program and it's kind of like an R&D machine, we're not doing roll to roll yet. We are aware that that's a big customer demand, and we will be implementing it. Currently, we're just doing sheets. The product name is the IO300 because the maximum size of the substrate is 300 millimeters. Mm-hmm. That's where we are today. That's not a constraint on the technology. That's just something that we did in the implementation. As we create the production machine, that size will increase and will also include automation.
Yep, thank you. Thank you. So, and definitely probably also the demands on the customers will give you then the direction for your further R&D work. Yeah.
Correct.
Thank you for that. So the machines are customers, that's always the best. Are you showing them also already on exhibitions, or because definitely people would like, so you have impressive videos, but probably people would like to also see it closely.
Yes, being a startup with limited resources, we will most certainly be having a machine at Productronica in November. Mm-hmm. We're still playing with the idea of adding another show, but that depends on our resources, basically.
Okay. So, yeah, thank you again, Ralph. I don't see other questions here. So thank you for giving us this insight on this award-winning, impactful technology. So let me move on with our next step in the presentation. So we've seen the two winners here, and now we refocus, and I would like to ask John to come on a stage. I would like to introduce him. You probably know him if you know something about LOPEC. John was always part of it, but he is now part of LOPEC in a new function. He is now running CAT market, and I would like to ask him to introduce himself also in his new function, and then move over also to introduce the new things we want to do with the startup competition.
Yeah, thank you, Wolfgang. I hope you all can hear me. Maybe Wolfgang shortly confirm that you can hear me all.
Yes.
Perfect. Sounds good. So yeah, my name is John Falter. Some of you know me probably. I was for a long time as the employer of Fraunhofer FEP in Germany, part of the substrates and encapsulation session. I was a share of the substrates and encapsulation session before. And this year, inspired by a European funded project on open innovation ecosystems, we have created a spin-off or an unofficial spin-off from the institute, which deals with technology transfer to industry. So we support industrial companies, mainly SME and also startups, to solve their technical problems as a coordinator of R&D activities with research institutes. Yeah, and that's our job. And for that, we build a technology database. But the main thing is that we are working a lot with people who have an idea for a business, for a new product, for a new technology. And yeah, in that sense, and together with the same moment that the startup chair, the position of the startup chair was open again, it was vacant again, the LOPEC asked me to take over the position, and I'm now the startup chair from next year on, and I hope and I will do my best to make the startup competition very strong and get really great companies and great opportunities also for investments and bring the people together at the next LOPEC and beyond. Yeah, and that's also my job now to tell a little bit about the startup competition. What I see here, of course, startups in the printed electronics industry, they're always, I would say, since 10 years, even 15 years, when we speak about Heliatech and Novalet and other companies, really, we have a lot of startups in the printed electronics industry. And the good thing is, there are two good things. The first, the technology is getting more mature, and the continuous stream of startups is not stopping. So there's still every year a lot of new companies coming up in printed electronics industry on the one side, and on the other side, speaking to several venture capitalist investors and business angel investors at the moment, there is a lot of money available that people want to invest, but they want to understand the technology, they want to understand what they are investing in, and the LOPEC will be a forum to bring these two groups in particular together. Yeah, that's the way how it goes. So what we want to do is we want to create with the LOPEC a startup network, a startup competencies. We want to improve the startup competencies, support these startups, but also support investors to find the gaps where to invest in and to want to bring them together and to help both sides. So for the startup competition next year, there will a few little changes, and that's practically what I want to show, Wolfgang. I think I need the next slide for it. Oh, it's already showing this. Okay, perfect. So what I want to show is that there is a call for paper for startup competition for next year. There will be a selection of the best startups that were 5 of them will present. I have another slides on that in detail, and I will present now in the next 5 minutes the jury for the startup competition. But the first question is, yeah, you have seen the winners from 2022. Ralph and Ofer, thank you very, very much for the great presentations that you gave. And again, congratulations from my side backwards to winning the prize this year, and now we are looking for the winners for the next year. So why should you participate in the startup competition? Wolfgang, would you be showing me the next slide? So you practically see 4 benefits for your startup, and to everyone in the audience who knows a startup that could apply for the competition, yeah, please forward the information to them. So at first, definitely you will increase your outreach and visibility in the community, not only with investors, but really with the whole printed electronic community and printed electronics industry community. Definitely, you will receive a feedback from investors, from qualified consultants, from experts in the field, both on technical, business, and on IP. And you will have the chance to directly get in touch with investors that are interested in investing in your company and in investing practically in your idea and business. And of course, the LOPEC, and that's not only for startups, is a good place to find partners and future customers for the company. With that, I would like to show a little deeper the modus, how it will work. The first step is that you're asked to apply on a website, the LOPEC Startup Forum website. You just see the link here on the screen. And there are a few questions about your business idea. And you describe your company, you describe your idea, you describe your current IP situation, the state in which your company is at the moment. And then we will send all the application on 14th January. That's the deadline. We will send all application to a jury out of experienced business people and CEOs, out of venture capitalists and business angels, innovation experts, and also we recruit our jury from intellectual property experts. Then this jury will select the 5 best applications. They will be invited to speak at the LOPEC Forum next year in the exhibition area, end of February, and to present their idea in front of an open audience, but in particular in front of a set of investors. We will have a 5-minute pitch and 5 to 10 minutes presentation, 5 to 10 minutes Q&A session. And during the LOPEC networking event, which is consequently after the LOPEC Forum, we will announce 2 award winners. So at least 2 award winners. There is the award for the best business case, and there is again the award for the most impactful technology and product. And we have something very special that is practically new. We will have an award for a free booth in LOPEC exhibition startup area for 2024. So this alone is a prize that's worth €2,000. So definitely that's an interesting thing to go. Definitely you should join the startup composition this time again, or this time I would say, not again. The jury for this year is composed, I'm the chair of the startup competition, so I'm also part of the jury. By the way, I'm playing the startup game by myself at the moment. So we just created the company a year ago, and I would say 3 months ago I started to do it in full time. We have some experienced business chairs of the LOPEC, Carrie Adams. We have an investor from the High-Tech Gründerfonds. Maybe some of you know Anne Umbach, or still from COPT in Cologne, and she has changed her position to the High-Tech Gründerfonds, so she's now representing the investor side. Michael Heck from Universal Display and UDC Ventures, Oliver Karl from the MEG Verwaltungs AG, and we have an experienced CEO from an organic electronics company that practically has made it and has launched a product and that is successful, and that's Heliatech here, Guido van Taatwijk, and Amira's investment, new in the game. Not sure who of you knows Rudolf Fritzek, who started his company earlier on supporting companies and SME and research institutes and accessing EU funding. Well, they've created an investment company, and they are very experienced as well with supporting startups in the field. And that's the jury for 2023. So these people will be live at LOPEC and will listen also to the 5 best pitches and select the winner for next year. Yeah, so in finally, just the important dates. The call for paper for the startup competition has opened in October. So you can immediately go there to the website and submit your business idea or your business, your company portrait. There is a deadline on 14th January when the startup call for paper will close, and we hope to have as many as possible applications and many as possible high-level applications for sure. And finally, on 1st February in the next LOPEC Talk webinar, we will be here to announce the candidates that will be invited for the LOPEC Forum and to pitch in Munich on the next LOPEC conference or exhibition. So thank you very much for giving me the time to speak, because that's all I want to say. And I wish everyone who now just started his application a good luck, and see you in Munich.
Thank you, John. Thank you for getting us some more details on the startup competition. I think we've seen from the winners of this year and also from previous winners where some of them really have moved from startup now to mature companies, that this is a very important process also for the industry to show the success not only in technology, but really in product and finally in successful business. So yes, that's one part of LOPEC to be also helping companies to move and get more successful. But of course, LOPEC 2023 is right before us. It's only a few months away, and I want to give you few updates. You definitely have received several emails to get you updates on informations, but that is really last minute information which I want to give to you. One thing is really the focus topics. Also, that is something I've mentioned in previous talks already, but I want to strengthen again the message that yes, mobility and smart living, these are our main focus topics, but we see sustainability as not something which is separate, but actually it's growing out of these focus topics, and it is definitely something we see as an organic movement that we can show more and more very good examples of business, products, and technology, which is not only used in the market, but also used in a sustainable way. So with that, I want to emphasize just one thing today, again, that is the exhibition, because that is really a very, very interesting movement and trend we see right now. This is the status of the application for the exhibition of today, and this is December 8th status, and we have already 120 exhibitors from 24 countries registered. That so far, if you know the number from this year, it was about 159 so far, seems not impressive, but 40 of them are participating for the first time. That is a very good number, but also the names which you see there, this is examples out of these 40 are impressive. That is one thing. The other thing worth to mention is if we calculate, and we have less time because it's LOPEC 2023 is early, as a 1 month earlier. Still, if we calculate this, we have an increase of 26% if we calculate for the same period, 26% increase, and also an 18% in the rented space. And I think both of this shows LOPEC is on a 2023 seems to be very successful, and we are working on it. And you will see not only that in the exhibition, but also on the conference. You see that the program of the conference, we have the call for papers, the program is now decided, and you will receive information next week about the program. It will be released on the website, so stay tuned and look out for the speakers which we can present for LOPEC 2023. We have one LOPEC talk even before the LOPEC itself. It will be on February 1st. John already mentioned it. We will talk about, which will be the startups which will be presenting, but we will also present the conference highlights. So stay tuned on February 1st to see again what you can expect at LOPEC at the end of February, in March 2nd. So that's the date. Save the date already on your calendar and mark it and be present. And yeah, if you see the state of the art, you will see it there live at LOPEC 2023. So thank you for your attention. Thank you also for all the speakers attending today. Thank you for attendance for this LOPEC talk, and see you next time in February. And have a nice and safe Christmas. Stay healthy. Thank you. Bye.